Hello. So let's start discovering session-based attacks. The first one is called session fixation. For this to occur, the application needs some kind of login mechanism. Session fixation means that the attacker is somehow able to set the session cookie in the user's browser before the user logs into the application. When the user logs in and the application keeps the session ID which is provided by the user, it uses that for the authenticated part of the application, then the attacker can use the session cookie which he knows in any other browser to connect to the application, and by that he can hijack the user's session. Let's look at this in a little bit more details. So we have the browser and we have web application. Let's see how it works in a secure application. You open the browser, you receive a session cookie, let's say AAA, but you're not yet logged in. So you go to log in, and then you receive a new cookie from the application. The first one, the AAA, will be invalidated, and you get another one, let's say B. And every time when you send a new request with B, then the web application will know that you're accessing your logged in session. The difference between the cookie AAA and the cookie BBBB is really important because this cookie has basically no value because it's not to an authorized session. So if somebody steals this cookie, they can only access those pages which can anybody do from the internet. However, this cookie here, that has a lot of value because if somebody can steal this cookie and connect to the application, then he will hijack your session. So it's very important that this cookie is protected. So this is how a secure application works. Now let's see our Voice of the Emperor application, how that works. So have Burp open and Firefox, and let's go to the Voice of the Emperor.
Lord Vader, the fleet has moved out to light speed and we're preparing to...
You have failed me for the last time, Admiral.
Yeah, it's intercepting. And we go to the admin page because here's the login. You can already check our cookies here. We have this cookie here, whatever. Let's log in and see what happens. So it's admin and long live the emperor. Login. Let's see in Burp what happened. Go to proxy history. And this is where the login was loaded. You can see we have this session cookie. And then here is with the post request, here is when we actually use our username and credentials. You can see them here. And after that, we don't receive a new cookie. So as I said, in case of a secure application, we should receive a new cookie because we are accessing an authorized session. And as you can see later on, the same cookie is used as before. So this is not yet the session fixation, but this is already a vulnerability what you can report to your customer. Because the problem is that even if the user doesn't log in, if the attacker is able to steal this cookie, and at some point when the user logs in, the attacker will be able to use the cookie to hijack his session. But let's see whether this website is vulnerable to session fixation. The difference between this problem and session fixation is that here we are using a token or an ID which was generated by the server. The question is whether the server accepts any ID, so whether it's possible for the attacker to to set this ID himself. So we are going to first test that in the repeater. So I will just take the request where we log in and send it to repeater. So go to repeater, and we are first just send it as it is. And you will see this happens when you successfully log in. You get a 302 redirect to the admin panel page. We can also test what happens when your login is unsuccessful. You get again a redirect, but to the admin login page. But what we really want to find out, what happens if we don't use this token, but we use something else, what, for instance, just a few A's. This is obviously a token which was not generated by the web server, so let's see how the web server reacts. As you can see, you got the redirect, and it redirects to the admin panel. That means that the login was successful, even though you actually used super simple token, and you also doesn't get any others. Let's try that in a browser as well. For that, first delete the cookies from the browser. Clear your recent history. Clear now. And I go to the proxy, go to options, because what we want to do, we want to change the cookie when the server sends it to the browser. But for that, we need to intercept the responses as well. So go to intercept server responses, check that you want to intercept them, and check also that intercept when the request was intercepted. In this way, we will see both the request and the response. Now go to the intercept tab, turn it on, and then reload the page. Or actually, let's start with the login. So in burp, this is the request without any cookie. Let's forward. And then this is the response. And here you can see that the server sets this anchor CMS cookie. Now we want to change that to, let's say, another one, BBBB. So a few Bs. And then forward. And then we can turn the intercept off and go back to the browser. We can check that the cookie is the BBBB. Here you can see it is. And let's log in. Admin, long live the emperor, and log in. We are logged in. First, let's check the cookie again. You could see that it's still BBBB, which is very good for us, attackers. Let's look at it in burp as well. Here is our login. You see its cookie is BBBB, and in the response, there is no cookie change. And in the next page, in the request, it's still BBBB. So basically what we could do, we could force the browser and the application to use a cookie which we know as an attacker's. You might ask how an attacker would exploit this problem. There are various ways to set a cookie, but the simplest one is physical access. So if there is any shared computer, like at work or in a library or wherever, if the attacker goes there and sets the cookie for you prior to login, then when you go there and log in, the cookie what the attacker set will be used, and immediately after you log in, the attacker will be able to hijack your session. That's the simplest, but there could be lots of various scenarios. So let's recap. What was session fixation? The problem is that when the attacker can set your cookie to a value he knows, and if at login the server doesn't change this value to another one, which is not known to the attacker, but it uses the value from the attacker, then this application is vulnerable to session fixation. Now let's talk a little bit about how to fix this problem. There are a few things which has to be correctly implemented to have a secure session management. The first one is long and truly random session values or session IDs. Like this one is not random at all. The second is that when you log in, the old token should be discarded and invalidated on the server side, and the new token should be generated for you for your authenticated session. And the third, that this should happen when you log out as well. So your authenticated session should be discarded, and then you should get a newly generated session token after logout. As an exercise, you could go to the source code of the Voice of the Emperor application and try to find out why it's vulnerable to session fixation. So this was our first vulnerability. I hope you liked it. There is more to come. So I will see you in the next lecture. Bye.
You are in command now, Admiral Piet.
Thank you, Lord Vader.